The architecture that Druid has is called a shared nothing microservices architecture. When you deploy a Druid cluster, you have lots of independently running Java processes that each one does a slightly different job and gets used in a particular way. Now, because it has this architecture, it means we can scale individual bits of the Druid cluster independently. We can add resilience, we can have replication. There's lots of really good benefits to it. So in this video, I'm going to show you what it looks like in a quick start and what the different processes do, but then we'll go a little bit advanced and I'll show you what a clustered setup looks like and how you can add and remove things and give you a taste of what happens when you do that. So let's start by looking at the Druid quick start. So I'm in my terminal. I'm just going to start the quick start that you probably used by now. And you can see it started up all those Java processes for me. So I'll go into the unified console. We'll go into the services area. And that's now going to list all of those independent Java processes that make up a Druid cluster. So we've got the router. That's what's actually running this console right now. That's like our central point of access to the cluster. Then we have the broker. The broker's deciding what route particular workloads should take. And one of those routes is ingestion. So the overlord and the middle manager processes work together to get data into a Druid database. And you can see there on the right hand side the number of slots that I have available for ingestion work. Now what we're not seeing on the console are the 3 dependencies for Apache Druid. And the critical one for ingestion is deep storage. It's an object store where when you ingest data in through those middle manager processes, the data gets OLAP optimized, it's columnarized, compressed, you get indexes applied, and that data is then pushed into this object store. And that data then sits there and it's queryable either through the overlord and middle manager, what we call query from deep storage, or you can pre-fetch it. That's where these 2 processes come into play, the coordinator and the historicals. Prefetching the data means that the broker has a very fast route to access your table data. In fact, it does it in parallel. It's a really important unlock for sub-second response times to your queries. And if I scroll over to the right hand side here, you can see that I've got a max size. That's the current capacity of that historical process. And then I also have shown usage. So in a quick start mode, by default, all table data that's been ingested will be pre-fetched onto these historical processes. And what's telling the historicals what to go and fetch is the coordinator. It's following these what we call load and drop rules. Now you might decide in a production environment you don't want to prefetch everything. You might want just a particular table or particular time periods in a table. That's fine. You can go and have a look at the load drop rules for that. But that's what's happening in the background. I've ingested my data. It's gone into deep storage. The coordinator's gone, oh, we've got new data. And then it's prefetching those onto the historical processes. Now there's another process that we don't see in the services tab. It's another dependency for Druid. It is Zookeeper. Zookeeper is sitting there to connect all these processes together. It's making the cluster aware of its own health, of its own capacity. Now to see this in action and see why we can scale different parts of our Druid cluster, and also to get a hint of what happens when you do move bits around, let's flip over to my Raspberry Pi cluster and we'll start and stop different processes. So here we go. On the left hand side I've just got my terminal windows open onto the different Raspberry Pi processes, and on one of the Raspberry Pis I'm going to kick off the master process. Now you can see the way I've configured the start Druid command here is just to kick off Zookeeper, the router and the broker. That means that I can get to the Druid console and you and I can have a look at what's actually going on, and then I've got the broker process just because that's cool and it fits into memory and it's nice. So let's get onto the Druid console straight away and we'll see these processes are running. So now let's bring up our overlord and coordinator. I'm going to start this on another one of the Raspberry Pis. Remembering the coordinator's there doing the distribution and balance, the overlord is in charge of these like workhorse for SQL ingestion and for asynchronous queries. Now we can have multiple overlords and coordinators running. It gives us a bit of resilience. So on these other 2 machines, I'm going to start more coordinators than overlords. For each of these coordinators and overlords, there can only be 1 leader. And handily in the console, as you can see, these have now started, and over on the right hand side I can see which ones are the leaders. So now we've got our multiple coordinators and overlords. For the point of this demo, we don't really need that many coordinators and overlords running. I'm quite happy with just one. This is just a very small environment, so I'm just going to kill off those processes. Now let's do something a bit more interesting. Let's imagine that we want to now actually ingest some data into our database. So what we're going to do is we're going to kick off some middle manager processes. And we can have multiples. So let's kick off 2 middle manager processes here, and let's wait for those to come up. And there we go. They've now been recognized. They've published their availability. And we can also see that they've published how many slots they have free. So we've got a total of 6 slots. One of those currently be used by something. I'm not quite sure what. It's just doing a maintenance task for us in the background. So let's start some other processes. Let's add a historical process. So this historical process, remember, is going to have a prefetched copy of the data out of deep storage. Means I can do really fast interactive queries. And there we go. Now we've got a cluster that has 2 middle managers and 1 historical process. And over here we can see just how much space the historical is advertising itself as having, which in this case is 100 gig. And it's also showing me just how much data has been prefetched onto that process as well. Let's say actually we want to prefetch more data. We're going to have maybe we're 6 months down the line and we want to have more data available for query through this fast lane that we've got. So let's add some more historicals. Let's stop first those old middle manager processes because I don't have an infinite number of Raspberry Pis here, I'm afraid. And we'll start off some new historical processes. And what we're going to be watching out for is once these, there they go, they've started up, is that we're now going to see data being prefetched from deep storage and balanced then across the cluster. That's in fact exactly what just happened. These, therefore, independent processes, the historical, the middle manager, the overlord, the broker, the router, it might at first glance be like, oh my goodness, look at all these complicated moving parts. But it's meant to be there to give you flexibility. If you want to scale up the amount of data that's being prefetched for those like really interactive, very fast sub-second queries, you can do that. Add more historical processes. The data gets rebalanced. It's prefetched automatically. Hey presto, off you go. Even on Raspberry Pis. If you need more capacity for ingestion or you need more capacity for asynchronous queries, I mean, you want a deep storage querying, that's fine. Just add more middle managers. Take them away again when you're finished. And then those leading processes, the overlord, the broker, the router, the coordinator, you can have multiples of those and Druid does automatic leader election between all of them. So we've seen all of that. We also saw that there's some stuff you didn't see, like the deep storage, Zookeeper, and the metadata database. And that deep storage being there to hold on to a copy of everything that you've ever ingested that you can then prefetch from there to those historical processes. And then you've got the Zookeeper, this glue that's making the cluster aware of itself and what resources it has available.